just a brief recap of what we've been doing for the past week. We started with the history of TRIZ, then we went on to do function modeling, where we had taken Mousetrap as one of the components, one of the systems for this we had done function modeling. Then we went on to cost reduction using TRIZ, where we used the same function model we had done in the previous day, and started doing trimming, where we realized that there should be a solution where the mouse catches itself, and you don't need a device to catch the mouse altogether. Then we went on to study contradiction, where we had two examples we had a look at. One was a fan example, and other was an example of the same mousetrap that we have been discussing. We tried to generate a few ideas here. Then we moved on to the contradiction matrix, where we saw what are the 40 inventive principles, what are the 39 parameters based on which the matrix works. Now today we are going to talk about evolution, the trends of engineering system evolution, or S-curve analysis, or S-curve evolution as we generally call it as. Is my speed fine, or do you guys want me to speak a little slow? I hope the audio is not clear. Okay, yeah. So I would want to speak a little slow. So what I'll possibly do is I'll close my video. Now probably the voice connectivity would be better. So yes, the trends of evolution. Just for the interest of those who were not a part of the previous sessions, what we are going to discuss today is not totally dependent on what we have been talking about in the past 1 week. However, if you have attended the previous sessions, you will be able to appreciate this topic better. However, those who are joining today for the first time, believe me, this will not be a bouncer for you guys. So you'll be in a position to understand it pretty well. So what exactly is an S-curve? On the left hand side of the curve, there's a curve that's visible on the right side of my slide. Is the audio clear now? I'm getting a few messages that the audio is not clear. Is it clear now? Fantastic. Okay. So on one axis, you see something that's called as the main parameter. The definition of S-curve says it's a curve which represents a non-linear relation. This is important. A non-linear relation between a change of a value of one of the most important attributes of the technical system and time. So the value of attribute being of utmost importance here. The value of attribute is presented along the vertical axis, while time is presented along the horizontal axis. So the value of attribute is of utmost importance when we try to study S-curve, because S-curve generally gives the relation between the value of that attribute, how the attribute has been performing over the years, since the other axis is the time axis. We read what is called as the value of attribute, and on the slide, on the graph, you see something that's written as main parameter. Now this value of attribute in TRIZ terminology is attributed as the main parameter of value. Okay. Now what would a main parameter of value be? The definition of TRIZ says the main parameter of value for a product is that feature of the system that impacts the customer's perceived value and purchase decision. So what is of extreme importance here is perceived value and purchase decision. And now as we move further, I'll explain you guys what is the difference between, right now quite a few of you also might be thinking that what exactly is the difference between a USP or a unique selling proposition and the main parameter of value from the TRIZ terminology. I know quite a few of you would be having this doubt in your mind. So what happens is a unique selling proposition is from the seller's point of view, whereas a main parameter of value is from the purchaser's point of view. When I'm trying to buy something, I say that, okay, this is one attribute in the product for which I'm ready to pay. Whereas a unique selling proposition is something that the seller has identified in his product, and that is something that he is trying to market to the customer as such. Now let's take the example of fan once again. We had this discussion on fan a couple of days ago, where we said that okay, uh, the dust accumulates on the blades of the fan. Okay, and we also said that the fan starts performing poorly over the period of time. Now, when you ask a customer what is the pain that he is having, he's generally not going to tell you that the pain is the dust or the pain is the blade angle. He will tell you, I mean, so how do you identify the main parameter of value? So the generally the ultimate test for the main parameter of value is you would tend to ask three questions. The first question being, does the customer really need that attribute in the product? If the answer to that is yes, then the next question is, are you getting that attribute in the system today? If the answer to that is yes as well, then the third question is, would you pay if I improve that attribute in the days to come? So that's the ultimate test of finding the main parameter of value for a customer. Let's say, for example, we said that right now you guys must have seen that there are dust-free fans that are on sale. You must have seen those advertisements for dust-free fans. So the dust-free fan that the company is selling is saying that okay, now I'm giving you a fan that does not attract dust or that does not hold dust. Now the company is still not marketing it that way. If they were to market, I mean, if you were a consumer and I said that I'm going to sell you a fan that gives you consistent flow of air over its complete lifetime, would you pay for it? A yes or a no? You guys can unmute. We are more or less in a little bit of a discussion mode. So you guys can unmute and we can have a small talk about it right now. So would you pay if I say that, I'm going to sell you a fan that will perform consistently over its entire life? Okay, so there are people who say that yes, they will pay. Now, will you pay when I say that I'm going to give you a fan that does not attach dust to? What would you be willing to pay more for? Whether for a fan that does not attract dust or whether for a fan that gives consistent air quality over its complete lifetime? What would you want to pay more for? The later one. So for the consistent air quality is what Riyaz is saying. Dr. Patel has the same observation. So the company that's selling fans that don't attract dust today, they probably need to start marketing it saying that I'm giving you a fan that will give consistent air quality throughout its life. So they have improved a feature, and the feature has led to overcoming a very undesired result that was there, an undesired output. I would still say that that particular product is still not being marketed properly. When you're trying to market such a product, you need to find out the attribute that the customer values the most of the feature that you have developed. So it's all about finding out that specific attribute that comes out from the feature that you're developing and telling the customer that, I'm giving you this attribute, and the customer pays you for it. So if similarly, I mean, for the dust-free fan guys, if you would have gone and asked the customer that would you want to pay for a fan that would perform consistently over the period of its life, they would say yes. Then the question would be, are you getting it today? The answer to that is no. And if the answer to that is no, and if you have developed a solution to it, then that's the best. I mean, that's a market winner for you. That's how you market it. So that's about the main parameter of values. So it says clearly that the impact that impacts customers' perceived value, not the actual value. It's not the actual value that we are talking about. It's the perceived value, and the perceived value affects the customer's purchase decision. So we have to be very mindful of what is the actual value, what is the perceived value that the customer is going to perceive of the attribute that I am giving to him. Let's look at a few examples of the main parameters of value for the different. I have intentionally tried to bring in the service industry here as well, slightly. Uh, so let's say if we're talking about an airline industry, what can be the main parameter of values? Probably on time arrival. That's what Indigo sells. Direct connectivity to various places. People don't want layovers. They don't want connecting flights. Connecting flights and layovers has their own set of challenges. Coverage, what all different countries it covers. If we talk about a car industry, what are the attributes that they sell? Fuel efficiency was something that they used to sell outright at one point of time. Comfort is that there's something that they sell. These days, safety is one attribute that they are selling a lot. People say that, gold safety standards. My car is a gold safety standard vehicle. You must have seen that in the ads of Tata Nexon. Now, if you talk about on the bottom left hand side about a travel website, say a Make My Trip or an Exigo, what is it that you would want to sell to the customer? Like, what are the channel partners that they have? As in, do they provide you booking for just Air India, or do they provide you booking for Air India, Lufthansa, all possible channel partners with good offers? How good or bad is their customer support? Sometimes people also would want to pay for their physical presence. What if I get stuck on an airport somewhere in a distant country, and then I have certain bookings and I have to modify those bookings? I would sometimes not want to keep speaking to somebody on the customer support uh, landline number or the toll free number for hours together. I would rather want to go across a window and just get it done as soon as possible. That's where they say that we are reducing the number of clicks when you come to my website. You get your booking done in 2 clicks or 3 clicks. So making life easier for the customer. What about a superstore? The presence, the local presence. Is it presence in my locality? Is it presence in my vicinity? What are the brands it associates with? What are the types of goods they sell? So these are the various attributes that customer wants to look at when they are trying to buy a certain product. So whenever we are trying to identify the MPVs, we need to find out what would be the need of the customer. This kind of is in sync with also another methodology of innovation, which is called as design thinking, where you say that you try to design products that are you have to make products that are designed for the user. So user-based design. So TRIZ talks about those things from the perspectives of main parameter of value. Let's take the example of PPEs. In the current COVID situation, PPEs are selling like hotcakes. People need PPEs. Forget about it being hotcakes. It has become necessity right now. So, who do you think would be the customer of a PPE today? I am waiting for your answers on the chat box. Who do you think is the customer for a PPE today? Healthcare system. Okay. Healthcare system. No, tell me the name of a person. Who? Government is an entity. Doctors. Who else? Nurses, who else? Nurses, fine, who else? But who purchases these for the nurses? Pharmacists, okay. We individuals, right? Government, municipal corporation, technicians, hospitals. But then we tend to forget one thing, that we are talking about uh, entities, bodies, but these entities, these bodies still have individuals who make them entities and who make them bodies. Government is an entity, but who within the government? The Department of Health and Family Welfare. But who within the Department of Health and Family Welfare? There is an administrative staff who is entrusted with getting these things procured and supplying it to the doctors. So who becomes the customer now? The customer now becomes the administrative staff who is purchasing it. It's not the doctors anymore. Doctors are being supplied by the administrative staff who purchases it for them. Yeah, for small clinics, the doctors may do it on their own, but then I don't think that's the situation right now. It's not the Ministry of Human Resources, it's the Ministry of Health and Family Welfare. Okay, so the administrative staff purchases it right now. Sometimes the doctors purchase it. One of the customers or one of the person is even the patient. So when you look at it from the perspective of a doctor, there would be different MPVs. And when you're looking at the same product from the perspective of an administrative staff, there would be a different main parameter of value. For an administrative staff, the basic need right now is the availability of the product. He would say that, I would buy it from you if your supply chain is really good and if you make it available to me within no time so that my doctors have it. If you look at it from the doctor's perspective, the main parameter of value from their perspective would be how good is the product. I should not be exposed in any situation whatsoever. It should be absolutely safe. So the moment we say that the main parameter of value is to be that particular aspect that drives the purchase decision, then we need to go back and see that who is the guy who's purchasing it. And then we try to understand that from the perspective of the guy who's purchasing it, what is it that's driving his purchase decision. So we say that MPV is something that has to be discovered. It has to be discovered over a period of time. Now, from MPVs, we move to what is called as value. Value in TRIZ terminology is the ratio of function to the cost. And we say that we should perform maximum function at minimal cost. That's how value is perceived. So we have up till now we have understood what S curve is, and the S curve generally has 5 different stages, as you would see on this graph. Stage 1, there is something that's called as the transitional stage, stage 2, stage 3, and stage 4. The S curve is dependent on the main parameter of value. It has one of this, its axis is representing the main parameter of value. Then we've understood what are the various examples of main parameter of value. Then we have studied what exactly value means. Now we move on to what is called as the S curve correlations. Now, at various positions on the S curve, uh, you can relate it to the level of inventions that are happening in that particular domain, the number of inventions that are coming up in that particular domain, and the profitability that you're deriving from the product that is lying on that specific position on the S curve. Okay, now that I said that S curve for a product, let me tell you that S curve for a product, when you try to plot S curve for a product, there are several different parameters of a product that you need to do an S-curve analysis of, and then there's a formula that you enter those values into to derive the S-curve for a product as such. At this point of time, I would want to share a small presentation with you guys of an S-curve analysis that we tried doing at some point of time. At this point, I would ask you guys to not take any screenshots because what I'm trying to share with you guys right now is something that's still in draft mode, and I would not want you guys to, you know, share it with anybody or take screenshots of. So this is for an air filter. This S-curve was done for an air filtration system or an air cleaner. This is how the evolution of air cleaner happened over the years. This is a graph that has been plot of how what is the level of inventions and the number of inventions that have come up in this domain from 1911 until 2016. So covering good 105 years. The parameters that were identified there were cost reduction, efficiency, integration to the super system, intelligence, maintenance, performance, reliability, and smart systems. Now you would see that there are two parameters that are listed here that they are different. One is intelligence and other is the smart system. I treat an intelligent system as something that identifies faults and tells me that there is a fault. And a smart system is something that identifies fault, tells me what the fault is, and auto corrects itself to work in those conditions. That's why they are identified as different. Based on the analysis, this is what the curve was for performance. Now, if you try to correlate this curve with the S curve that I showed, this looks at late stage 3 or moving towards stage 4. This was the situation with the cost reduction. This is what the efficiency was. Efficiency definitely looked like something that is going towards stage 4. So probably right now people are not interested in efficiency anymore. Integration, intelligence, maintenance is one curve that you see that it's still rising. And the other attribute that you would see is still rising is the smart system. So the idea mainly was that these are the two domains that you probably need to work in if you're working in this particular product segment. So these are the areas that you should probably work in to gain more profits. Now trying to correlate it with the S curve that we were looking at right now, let's go back to the previous presentation. Screen visible? Yes, no, guys.
Yes.
Okay, great. Okay, so now you see here, this is the stage one, and this is where the transition stage starts. You see a lot of inventions happening in this domain because quite a lot of people are doing research in this area. At the same time, over here you see that the profitability of the invention curve is on the negative side. So that essentially means that the cost is only being spent, nothing is being recovered right now. We are spending a lot of money, we are not recovering anything, but there is. Hello?
Oh, yes.
Hello?
Yes, Ron Bhai. Please tell me.
The voice is gone. I was hearing a lot of echo. Okay, fine. We'll go back to the presentation. So yes, here you see the correlation, a clear correlation on where exactly is a particular attribute on the S curve, what would be the level of invention, the profitability from those attributes. So it clearly says that until the product is developed up to stage 2, you would not start seeing profits. From the transition stage or early stage 2, you start seeing profits. And people who say that, you probably at this stage itself, you need to start going into the next product, they tend to discount this fact that when the curve moves from stage 2 to stage 3, that's where you gain maximum profits. So in this region, you will see a lot of invention again happening somewhere when things go to stage 3. Because at this point, what people are trying to do is they are trying to retain their market share and file patents that would, in an ideal world, would be called as evergreening of patents, but that's not to be. So they are trying to file patents on smaller attributes of the invention and retain their market segment. That's the reason why you see there's a hump here again, and the number of invention goes up all of a sudden when it tries to move to stage 3. So that's the correlation between the different stages of S curve with the level of invention, number of inventions, and profitability. And the level of invention you see when the invention is in stage 1, the level of invention is high, it tends to go down because the interest is dwindling at this point of time. You don't really know whether the product is going to see the light of the day or not. Okay. And then when it moves towards stage 2, the interest gains again, because at this point of time you have at least one customer or somebody who's trying to say that I probably need this product. So at this point of time, people start inventing again, and therefore the level of inventions go up. And over here in the third stage, you see that though the number of inventions are high, but the level of inventions are very low, because at this point of time there is not much left for somebody to invent in that particular domain. And when I'm talking about inventions, don't perceive this for products only, or for mechanical industry, or for industry specific. These inventions can be innovations in the service industry as well. Now let's move to the next topic where we start talking about the trends of evolution. Now that we have studied S curve and seen that the S curve follows a certain pattern, it goes through 5 different stages: stage 1, stage 2, stage 3, stage 4, and there is a transition stage that comes between stage 1 and stage 2. So this is what would be clearly summarized or told to as trend of S curve evolution. Now, trend of S curve evolution is subordinated by trend of increasing value. We just now studied what exactly value is. Value is the ratio of summation of function to the summation of cost. So that essentially tells us that value would increase if the function increases but the cost decreases. Then trend of increasing value further has 5 subsets: trend of transition to super system, completeness of system components, degree of trimming. When we were talking about cost reduction and trimming, we had seen that ideally, I told you the definition of ideality, which means that a system should not be needed. An ideal system is no system at all. The function should be delivered and the function should happen on its own. That's an ideal system. So as the trend of these are trends of increasing value. So as the value increases, the degree of trimming should increase. The system should move towards ideality. Then the trends of optimization of flow and the trend of coordination. Now the trend of coordination further has 2 sub-trends, which is the trend of controllability and the trend of dynamicity. Okay, so now we will try to look through an example each of these trends that we have spoken about just now. But before I get into that, I would want to give a 5-minute time to you guys so that you guys tell me what is the question that you guys have until now. Because what we are going to cover next is going to be based on what we have understood until now since we met today and from 2 o'clock. So coming back to the chat box, tell me if you guys have any doubts or you guys are perfectly fine with whatever we have taught, or we can also unmute our microphones and start talking. We'll give like 2 minutes for it. So I have a question here from Naveen. Where the bar size for each curve is coming from? Patent count disclosing the particular attribute, example intelligence. So Naveen, to answer your question, patent count is one parameter. Other than that, we have also identified how many innovations has happened in that domain of intelligence until now in our industry or in aspas ka industries. Can you give an example of value calculation? Now this is a very interesting one. Can you give an example of value calculation? If you could make last 15 minutes inculcating the whole session application based by taking a case study. Okay. So, Riaz, to answer your question, if you could make last 15 minutes inculcating the whole session application based by taking a case study, what I had shown the S curve for air cleaner was pretty much a case study for S curve analysis, where we drew S curve and said that smart system is probably what you need to start working on. If we have our product, so that the price should we keep? If we have our product, so what price should we keep and what should we do for moving it forward? Smith, you have a question. If we have our product, so what price should we keep and what should we do for moving it forward? First of all, who told you that price is the primary governor in your product right now? You need to first decide, is the price the primary governor? Is the customer only looking for a low price product? What exactly is the stage is that at that particular for that particular attribute of price, what exact stage is the product at right now? I think we'll move ahead here and then you guys will understand further. Now, see, when we are talking about price and value, you see values of summation of function and cost alongside the S curve. In the first stage, it says the function should increase, but the cost should decrease. What is the reason behind it? The reason behind it is at this stage, you are already in losses. You are not earning from the product, and your product is still testing the waters in the market whether it will really stand or not stand. So at this point you really can't afford of- to increase the price at all. At this stage you need to focus on the functionality, improve the functionality of that product for that particular mpv to the extent possible, and try to bring down the cost, manage the cost to the extent possible, because by the time you move from stage one to the stage transition and second stage, by you will get a lot of leverage to increase the price. So when you reach move from stage one and when the market starts accepting it, you have the opportunity to increase the price as well. Whatever loss you have made in stage one, you will be in a position to recover it greatly. So as you move towards stage two, the idea, see, now there is one very interesting thing that you see here. As you move from stage one until this point, that's somewhere between stage two and stage three, you are recommended to keep increasing the functionality. And this is the stage where you are asked to reduce the cost, you are asked to keep the cost constant. But this is the place where you are told that you can increase the cost and start gaining the profits that you profits for the counter for the losses that you had in the previous stages. Now, as you move towards stage three, we say that now we don't need that functionality anymore. The market is saturated. Like we saw in the case of efficiency for air cleaner, it was somewhere here. The efficiency has already moved a stage where it is at 99.9 or 99.97. You probably don't even need efficiency anymore. अभी जिस stage पे है, that's good enough. You don't need to increase it. But right now, what the market wants is it wants you to reduce the cost. But you're not allowed to reduce the functionality. You have to reduce the cost, keeping the functionality constant. This is a point in time where a lot of competitors have already entered into the market. This is a point in time where the patents that you filed at this stage have probably expired. So you don't have a lot of leverage in the market. So at this point of time, the only thing that you can do is work on something that can probably help you jump to the next S curve, or reduce the cost, do some value engineering. Yes, somebody said something. Here trimming comes. Yes, true. Here trimming comes. That's right. So to bring down the cost, the trimming would come in place over here. And trimming continues to be here. So by the time you come to stage 4, you say that I don't even value this functionality anymore. I want the cost to come down drastically. I don't care what the functionality that you're delivering at this point in time. Guys, just give me a minute. I'll be back. Just give me 1 minute. Really sorry for the interruption, guys. I'm back again.
Hmm.
Okay. So I think by now you guys would have understood to some extent what is the trend of increasing value, and how is cost and function interrelated to each other, and how do they interact in the various stages. 1 minute for questions. If you guys have any questions.
Hmm. Hmm.
Okay, so I think there are no specific questions. We can continue to move. So over here we have covered the trend of increasing value. Somebody is trying to ask. No, sir, no.
Hmm.
Now we move to trend of transition to super system. Now you guys remember we spoke about system and super system in the past, right? There is a system, there is a subsystem, and there is a super system. Say for example, if if we talk about a pen, if a pen is a system, then the user is the super system, and there are all those things that are outside of the pen are the super system to the pen. So now we talk about trend of transition to the super system. So as the system wanes out, there is a need for integrating that system to the adjacent systems. Okay, transitioning to the super system. One interesting example of that is, we used to have this desk and chair in the schools and colleges at some point of time. From that, it has moved to now this, where the chair and the table are integrated to one another, and it has further moved to a stage where there's just a plank that's covered to the handle and it comes down. Okay, this is trend of transition to the super system. Now we talk about trends of decreasing human involvement. And guys, I think you guys must have felt this quite often. Tell me if you guys have felt this happening very often.
Hmm.
Guys, this is a presentation not visible.
No, it's not.
Oh, sorry. Sorry. अरे तो बोलना चाहिए ना यार. You guys should have told. I'm continuing assuming that the presentation is visible.
Still, it is not, huh? Rohan bhai?
Yes. Just give me a moment. अब है.
I think coming. Yes, now it is.
Okay, so we spoke about trends of transition to super system. There are people who are saying something in the chat bar. Just before 1 minute, no screen. Okay, now it's there. I think that's resolved. So, how many of you have experienced this, the trends of decreasing human involvement? How many of you have experienced this? I'm sure many of you must have.
Yes. Hmm.
So, can you give me an example of trends of decreasing human involvement? One example. Alexa, robots, autonomous vehicles, perfect, fantastic. ATMs, great. And now we are talking about robots who can administer medicines in wake of COVID-19. We don't want humans to be moving around. Industrial machineries, UPI, perfect. Now I'm going to give you an example where I'm going to show how does this transition happen. People used to walk for transportation at one point of time. There was full involvement. Then came this cycle where the main function of movement was transferred to the wheels. Okay. Then came this scenario where there was chain and sprocket involved, and at this point of time, the transmission was transferred. You just had to pedal, and the chain and sprocket did the job of moving the vehicle. Then you move to this stage where the energy source itself is transferred. Earlier, you were the one who were driving it at this stage. Then, at one point of time, the energy source got transferred to the engine. You just press the accelerator now, and then the controls are transferred as well. You just stand on a segway, just a nudge, and it takes a right, it takes a left, and there are segways which you can, which are integrated with maps. You just put in the maps and they take you there. Or the driverless cars that we are talking about, which is yet to become a reality, but then it will become a reality in days to come. So this for you guys is the trend of decreasing human involvement. Now the trend of flow enhancement. At one point of time, the flow is very random, with no stoppages, no signals, nothing. Things are flowing as they are flowing. Then we try to bring in some sort of discipline to the flow. Then when the flow becomes unmanageable even with these disciplines, we tend to bring in additional channels of flow. So you see these multiple highways, bypasses, overhead bridges that you see there. And then you bring in additional modes of transportation as well. You see metro rails there right on top of these bridges. So that's trend of flow enhancement. I've tried to bring in an example from the perspective of traffic control so that everybody would be in a position to relate to it. Same is the scenario in the case of engineering systems as well. If you guys remember, we said that, in the example of segmentation, we were saying that if we don't want turbulent flows, we can have multiple small channels for the flow to be allowed inside a system so that the flow is not turbulent, it's streamlined. Okay, so now we next move on to trends of increasing coordination. This is the umbrella. How many guys has this has happened to how many of you guys? This must have happened to quite a lot of you guys, isn't it? So why does this happen? I'm waiting for your response or something. Why does this happen? We can unmute our mic, we can discuss over here for a couple of minutes. Not managing angle with the airflow. Bingo, Dr. Patel, you have the answer. Perfect. Moving in opposite direction to the wind. Fantastic. This has also happened. It's raining. It's raining cats and dogs. An umbrella is supposed to protect you. but the umbrella is not able to protect itself. If the umbrella is not able to protect itself, how is it supposed to protect you now? And
mm,
how many of you
mm,
have seen this? This is called a sense umbrella. Now, what a sense umbrella does is it ensures that the air has a path to follow and it does not dislodge or interrupt with the coordinates of the umbrella as such. It provides a streamlined flow for the air to take a path and go ahead without hampering the umbrella altogether.
mm,
So this is trend of increasing coordination. Now you have started coordinating with the way the super system is. With that, we come to the end of trends of engineering system evolution. I have tried to take one example each for most of the trends. And there is one trend that I would want to cover once. This is this trend of increasing dynamicity. This is an increasing. This is a very interesting trend. Uh, this trend says that something that was one piece will go on to become two pieces. Will go on to become with multiple joints. At one point of time, the joints become flexible, and then at one point of time, the whole system becomes flexible or it vanishes. That's the trend of dynamicity. A very simple example is, the doors in our house. At one point of time, uh, the doors in the houses were just one single door. Then the door became such that there were two parts to the door. Then came the sliding door, which was broken into multiple parts and had multiple joints so that it can slide in one corner. And then we came to it's may like blockchain system. No, blockchain is somewhat different from this, Raghavendra. So I generally try to tend to take the example of doors over here. That's how I go. Or if, for example, if we talk about even specs, the oldest specs that we had, they did not have these folding frames. So you would not be in a position to fold them. They would be like piece of glasses kept on your nose. Then it got hinges. It started getting folded. Then the hinges got springs. So now they could take the outer lateral movement as well. Then you guys must have seen those tiny sunglasses that fold into a very small one lens size that can be kept inside the pockets. So the number of joints are increasing. And then you guys also must have seen those wire frames where the frame becomes flexible altogether.
mm.
Uh, I'll just give me a moment. So if we are talking of that trend, we had those old frames where these were not folding. You guys can see me on the camera. Then the
Yes.
frames came with child these hinges. The frame would fold. Okay. And then the frame, these hinges had springs. The frames would go outward. And folding becomes flexible. We have these diagrams. Okay. Those became flexible. So that for you is trend of increasing dynamicity. Nowadays, most of the research-minded companies are adopting the concept of bionics and TRIZ. Yeah, Dr. Gadar, that's the way to go probably. So that for you guys is trend of increasing dynamicity. with this, we have covered the topic for today. Now, what I would like you guys to take through is what the question that was asked to me right at the beginning, that how do students become a part of this TRIZ. So just to tell you guys, I have been joined with one of my colleagues and a good friend, uh, Professor Sandeep. He has been through us through this session for this session throughout the week. He is the he's the main evangelist of TRIZ, and he's the person who runs the students chapter of TRIZ. Okay, and now I'll take you guys through a small presentation on the students chapter of TRIZ. Um,
Hmm.
Sandeep, you can probably try and unmute your mic so that you can also talk if you're available there. Sandeep, are you there?
Yeah, I'm there. Can you hear me?
Yeah, I can hear you.
Okay.
Okay. So yes, Dr. Vankede for you guys. Dr. Sandeep Vankede is the chairman TRIZ chapter, TRIZ Association of Asia, students chapter, and chief evangelist and consultant of TRIZ Asia. Sandeep, you can take us
Yeah,
through the presentation of the students chapter.
yeah, Dr.
Okay.
Sandeep,
Yeah.
welcome to our
Thank you,
session.
sir. Thank you so much. So basically, TRIZ is being taught in many universities, though it seems that it is new. But basically, this is a slide wherein you can see how many universities all across the world are taking it as a course. It is not just some additional courses which are conducted. This is being involved or covered under the entire syllabus or curriculum itself. So right from when students are there in first year, since then, small tools are being made aware to them, and gradually, by the time they reach to the graduation and they are actually supposed to perform their project work and all, they are ready with this. So, run next slide, please. Yeah, so this is preamble. I won't take much of your time because we are already near to 3 o'clock. I'll share this presentation with all of you who are the participants here, and you can just contact me. The basic idea was to start it is that the student should be aware, and the challenges nowadays are altogether different from what they were earlier. So development and application of the TRIZ methodology for development of innovative abilities of a person, and all these things were the basic intention behind starting this chapter. Next. So goals were basically to nurture the creativity potential and fostering the global competencies, lifelong learning in all domains. Generally, people think that TRIZ is only in mechanical engineering or service or management, but basically it is even into softwares. So there is no domain wherein it is not there, because everyone basically needs the creativity. And if you need creativity, any domain is your domain to learn the TRIZ. Okay. So last point, if you see, to facilitate the AICT innovativeness, so we have many chapters which we have to start in our institutes and being made mandatory by AICT. So our TRIZ chapter very well aligns with these activities, and we can get these things done much better than others. Next slide, Ron. So benefits to the students or faculty members or institute. Basically, this chapter is not only limited to students, it is also for faculty members, and there are many industrial people also who are interested in this. So in fact, when we started it with the students chapter, but many faculty members said that we are also interested. So we increased it, and when we go for consultancy to various industries, and when they see my card, like a student chapter chairman, they say, why you are limiting yourself to students and academics only. So there are now many members from industries also. So point behind this is that this would be a larger group gathering wherein we can have very good interactions. So it has got an association with the international TRIZ body, that is TRIZ Association of Asia, and our parent body is GenTRIZ, which is one of the biggest TRIZ practicing consultancy firm all across the world. And Matris, what you might have seen in the like introduction of Rohan and mine also, that we are graduated from Matris. Matris is basically the university, and this Matris is actually following the syllabus and course notes of Gentris. So you can just understand how big this company is. So we'll be conducting many TRIZ training at the institute, and institute can also further have certain courses conducted through us for other people also. We understand that there are many requirements from faculty nowadays to have the resource generation, and we have to have some money to be earned, maybe through some training program organization or maybe through consultancy. So this TRIZ chapter will definitely and is being used by many faculties for doing so. So we'll be coming across to you and we'll be conducting so many things and you can just go through it. Next slide, Rohan. So these are some sample topics on which we can develop. These are just a very few, and we also have our expertise in those areas in which even industries are not being very aggressive as of now. So right up to learning from the basics of creativity up to the level wherein we can patent it, and not only patent, we can also go ahead and circumvent an existing patent. And this is being done exclusively. And Rohan is one of our resource person to get it done. Next slide, please. These are the institutes wherein we are already working and we have conducted certain activities, and many more are adding. Just now, after at 4 o'clock, I have to make a presentation at a institute at Nasik also. So there are many institutes. Just to put a few, I could gather these logos. Next one. And just a few words about TRIZ Association of Asia. As we can see, it is a regional representative of MATRIZ, and we have on our roll many people like PhDs, IIT graduate, TRIZ level 3 practitioners. And if you see, we have a GKN, that is known as Global Knowledge Network, and we have 8,000 plus scientists worldwide working for us. So basic things on which we work is increasing in ROI and innovation strategy and increasing innovative impact to any. These are actually working for industries. Next slide, Ron. This you can actually get through our website, that is trizasia.com, and you can see all those details on which front we are actually working. So we can go ahead, Ron. You can see innovation, portfolio, problem solving, concept substantiation, verification, and these are our global partners which you can see. And what we do, as you might have understood by in the last complete week, that many a time people just spend their time on understanding or addressing a wrong problem. So basically our MPV, which is a biggest forte which we can have, is finding out the right problem to be solved. And we all understand a right problem identification is always a halfway done. And in one of the slides of Rohan, you might have seen, like just for identifying a problem, how many tools do we use? So extensive process, and definitely institutes need it, because unless and until students get the knowledge of the trend or the methodology which is being used worldwide, there are many evidences how it works. The moment we have held hand with GE, Samsung, and many industries, you can see exponential rise in the patents, whatever they have. Right now, I have not put that slide over here, but immediately within 1 or 2 years after hand holding with these industries, the patents have risen like anything. And there are many other case studies also wherein Panasonic was losing its market to some Chinese product, and it was a huge problem for it. And there was hardly an intervention of 8 to 9 weeks, and then there was a product developed, that is a shaver which you can find on Amazon also, which has brought such a high value and such a low cost, both things. And the many like as Rohan has said, trimming, function oriented search, these kind of things were being used, and now only that product has given $50 million business to Panasonic every year. You can just imagine like what is the value which is given through this methodology. If you have any queries, please let me know. I would be very happy to answer them. Last slide, Rohan. Next slide.
I have moved. It's moving.
Okay. So these are just to give you the details. And you can call me or just send me an email. You have got all the details of Rohan also. So guys, you
Okay.
can just unmute and ask any questions if you have, or any doubts or suggestions as well. Most welcome.
I think, Sandeep, I have a question for both of
Yeah.
you, to you
Okay.
and Rohan.
Yeah.
There are different levels of TRIZ experts, level
Right.
1, 2, 3, right?
Right.
So, and, is there any level above 3 as well? And what is the
Yeah.
main difference between these levels?
Okay. It is like when we go for graduation, like step by step we learn. So similarly, these courses are there. And day one, I suppose Rohan has also introduced like what is level one and what is the duration of a course. Level one is generally 32 hours for faculty and students, whatever we have. But then when we conduct it, we do not conduct it at a stretch. When we do it for industries, definitely we do it at a stretch, 3 or 4 days at a stretch, and we finish it because it becomes very difficult for them to spare time. But then for faculty, wherever we have done at institute in Nagpur, Pune, and Mumbai also. So wherein we have spread it across the days, so that one tool or one methodology is taught and you can practice on that, and then we can go ahead. So level 1, then level 2, and level 3, these are the 3 levels in which we have classroom teaching. So level 1, as I've said, is around 4 days, 8 hours a day. Level 2, it goes around 10 days, and level 3 again it goes around 15 to 20 days, depending upon like what is the expectation in that. We can also work with the projects also on that. And then this is not a continuous process. There would be a gap of 6 months between the two phases of level 3, because that is the last level wherein we'll be interacting with the trainer. And after that, level 4 is equivalent to what we have got as our PhD. So we have to take an problem right from the base, what all tools we have used, what are the outcomes of that, and 2 patents are expected through this. And at the end of that, there will be a defense. Even level 3, there is a defense wherein two experts from different countries, they'll be asking question. And just to tell you the gravity of courses or the gravity of certificate which they have, so at level 3 there will be an interview. And if one of like earlier it was samples, but now 100% of the participants are there. And if suppose I am conducting some courses and there are 10 students who are learning through me, and if they are not able to answer it, what will happen, that certificate those people will not get, and even my license will get cancelled. So that is the level of what you can say difficulty they have put into this. Then level 4, it will be open defense, and level 5 actually is that the person who is expecting this has to face a open defense. Every year we have a conference, international level, and in that that person has to either do a very substantial work or add to the knowledge of TRIZ. And that is what Rohan has covered today, S-curve. It seems such a small topic, but among many TRIZ masters, I personally know 3 persons who have done their master level, like TRIZ master, on only this S-curve. So every time we interact with these TRIZ masters or experts in TRIZ, every time they come with some different thing. I'll just add one more line in that. In 2013 I happened to meet Mr. Dr. Sergey Ikovenko, and I asked him what are the good books to learn, and he said like you cannot learn TRIZ from books. So at that time I was just thinking, okay, हर एक को ऐसा लगता है, and everybody would be saying like this कि book से नहीं सीख सकते. But since last 6 or 7 years, I am interacting with these people, and every time, Rohan will agree to me. Every time they do not speak the same thing. Every time they have different example. Every time they have different level of discussion over there. So this is still to be learned by gurus. That is the thing. But definitely not, because for level 1, level 2, yes, there are standard syllabus and everything is there, and we can do it very well. I hope I am able to answer your question. Rohan, if you want to add something.
No, I think Sandeep, you have pretty much covered everything. Uh, no, TRIZ level is not awarded to a person on the basis of he has a patent or not. TRIZ certificates are awarded based on the training that you have undergone and the examination that you have cleared. The certification only happens based on that.
Yeah,
Riaz, I
Mr.
think, had a question.
Sorry.
Mayur Hedu is asking, could you share comprehensive details on courses, plans, and fees?
Sure, we'll
Mayur,
do it.
I have given my mail ID, or there's the mail ID of Dr. Sandeep as well. You can send us an email and we'll revert to you with all the details. Or you can probably type your email ID. We'll get back to you. Please share your email again. Okay, fine.
And we'll share the details with Dr. Amit also, Dr. Amit
Yeah,
Patel.
we will share that presentation of this student chapter with Dr. Amit. You will have all the details.
I will share the same with all the registered participants. Sure.
Yeah, please. Thank you. Yeah. And just one more thing, like someone asked about fees. So it is not an intention to earn money from that. These are just to have our basic things you can understand when we have to travel and when we spend some time. So there are some basic requirements, and for that only it would be not ranging from for annual subscription of a student to faculty. We have different like the fee structure put on that I'll be sharing, but that is merely 350 rupees to around 600 rupees. You can just understand, not more than a dinner. And that was entire 1 year fee. And we have further discounts also for more numbers and more years of subscriptions and all that stuff.
So, guys, any more questions? I think with that, we have come to the end of a week-long interaction that we had to give you a brief of TRIZ. And like we are going to share our coordinates with Dr. Patel, Dr. Amit Patel, and the TRIZ chapter presentation as well. And you have my coordinates. If you have any specific doubts, you can get back to us. We'll be more than happy to resolve those for you. I think, Amit, with that, we come to the fag end of today's session and complete session on TRIZ.
So, yes, this was really a very fruitful week for all of us. And we are really happy to host you during a full week. This was very insightful. You covered a very different aspect from history to the functional modeling to the functional approach, contradiction, metrics of solution, and the trends of evolution through trees and the student chapter of trees. Different software solutions where it is applicable and important aspect. It can't be taught through books, right? You have to get into multiple aspects and different segments, right? I hope it would be really fruitful to many of our participants, and we'll expect to see at least some of the participants to get through into professional training and have a certification on trees as well. Right. So we are thankful to you, Rohan, and also to Dr. Sandeep for being with us during whole of the week. Thank you. Thank you very much.